Hello friends, this question is from the subject of analog. It's a linked data question. In this question, one NMOS is given, and it is given that in the circuit we have a 2 voltage source. One is Vs plus, other is a Vs minus. Vs plus has the magnitude of plus 1.5, and Vs minus has the magnitude of minus Vs5. The K is given as 1 milliamp on volt square, and threshold voltage of the MOS is 0.5 volt. And there is one input source is connected across the gate. And in the first problem, this question says that to find out the value of RL such that for output should be 0, for input is equal to 0. We need to find out the RL under such condition that if our input is equal to 0, my output should be 0. So first examine that in which region this transistor is working. Let's find out the value of VGS minus VT. So my VGS is V in minus Vs minus Vt. So it is V in minus of minus 1.5 minus 0.5. So it will be equal to V in plus 1 volt. So for this case, when my input should be 0, because I want the output should be 0 for input is 0. So in this question Vgs minus Vt is equal to 1 volt. Okay, now my VDS is Vd minus Vs. Vd is connected to the Vs plus. Okay, and S is connected to the Vs minus. Vd is connected to the Vs plus through one resistor. So VDS is Vd minus of minus 1.5 is equal to Vd plus 1.5. So in any case, Vd plus 1.5 is always going to be greater from 1 volt. So my VDS is greater than VGS minus VT. So my transistor is in saturation. Okay, now if I can apply the KVL at this input loop, if I may apply the KVL at the input loop, so I can start from the Vs plus. So it will be Vs plus minus ID RL. RL is the resistance across. RL is the resistance minus V naught minus Vs minus is equal to 0. For this case, my V naught is 0. V naught is 0 because I am working on the condition where input is equal to 0, output should be 0. So my V naught is 0. So my ID RL is Vs plus minus Vs minus. It is 1.5 minus of minus 1.5. It is 3. So my ID RL is 3 volt. This is I have got. So ID is a saturation current, saturation transistor drain current, and I need to calculate the value of RL. So if I may put the value of ID here, so I can easily calculate the value of RL. So now let's find out the value of ID, which is drain current of NMOS in a saturation region. So it will be easily calculated using the drain current formula in saturation region. So let's apply the formula, which is K by 2 times VGS minus VT the whole square. Vs minus Vt is 1 volt, which you have just calculated. So it is half into 1 square, which is half milliamp. So my ID RL, which is equal to 3, is half into RL is equal to 3. So I have calculated the value of RL as 6K. ID is in milliamp, so resistance is in kilo ohm. So my load resistance is 6K. So my answer of my first question is 6K. So in the next question, in the next problem, the question says that as Vin is increased, now if as Vin is increased, the output voltage Vout decreases. For the value of RL found in a part A, which is 6K, what is the minimum output voltage Vout such that MOSFET will obey the saturation discipline? We need to find out the minimum output voltage, or that output voltage that minimum required such that my transistor will remain in a saturation region. So in other words, I actually want to make a condition and to establish a condition over output V naught such that my transistor always work in a saturation region. Okay. So in a first problem, we have calculated the value of RL as 6K